What mass of hydrogen gas will be liberated when 6 grams of magnesium ribbon dissolves in 500 cm³ of 6.0 molar HCl? And we're given the relative atomic masses of magnesium and that of chlorine. All right, this is a question that has to do with limiting reactant. The limiting reactant concept will come into play here. Let us get straight off into it. The solution. Now let's write the equation of the reaction between magnesium, that's in the solid state, magnesium ribbon, react with diluted Cl. 2 moles, of course, are required. Aqueous, solution of an acid, and we form the products: magnesium chloride, aqueous, a soluble salt, and of course the evolution of hydrogen gas. This is the equation of the reaction. And now 3 substances are mentioned. What mass of hydrogen gas? Number 1, hydrogen gas. Let's take note of that. Will be liberated when 6 grams of magnesium ribbon, magnesium, number 2, dissolves in 500 cm³ of 6 molar HCl, number 3. So there are 3 substances here, and this is the feature of the limiting reactant problems. Now, let us establish in this equation of the reaction, 1 mole, that's the stoichiometric coefficient here, 1 mole of magnesium requires 2 moles of hydrochloric acid for the formation of 1 mole of hydrogen gas. So which of these 2 reactants will be employed in the calculation? We have to determine which of them is present in limiting amount. Let us establish the number of moles of each of them. Now, the number of moles of magnesium is given by the mass provided divided by the molar mass. The given mass divided by the molar mass. Let us go to that. The given mass of magnesium in the problem is 6 grams. 6 grams of magnesium divided by the molar mass. And the molar mass is 24 grams per mole. And this will give us, of course, 6 divided into 24 4 times. And 1/4 is actually 0.25 mole of magnesium. Good, beautiful. In a similar manner, we want to determine the number of moles of hydrochloric acid present. 500 cm³ of 6.0 molar hydrochloric acid. In this case, the number of moles of hydrochloric acid is given by the molar concentration in mole per dm³ multiplied by the volume in dm³. Now, in the situation where the volume is in cm³, then we will need a conversion by dividing by 1,000. And that's going to happen here. So this is going to give us molar concentration of hydrochloric acid, 6.0, multiplied by the volume of hydrochloric acid, which is 500 in cm³, and to convert it to dm³, we divide by 1,000. Yes. And now, division process. 500 divides outrightly in 1,000 gives us 2. 2 divides into 6.0 gives us 3.0 mole of hydrochloric acid. And now, we can judge clearly from our stoichiometric coefficients, 1 mole of magnesium requires 2 moles of HCl. So 1 mole of magnesium requires 1 mole of magnesium requires, I'll use the equivalent sign, 2 moles of HCl. And let us take the lower amount, 0.25 mole of magnesium. What would that require by simple proportion? 0.25 mole of magnesium will, of course, require, we multiply by 0.25. So let us go for that. That will be 2.0 multiplied by 0.25. And that will give us 0.50 mole of hydrochloric acid. This is simple proportion. 1 mole is equivalent to 2 mole of HCl. So 0.25, which means multiplying both sides by 0.25. 2 multiplied by 0.25 gives us 0.50 mole of hydrochloric acid. This is the amount of hydrochloric acid required for this reaction to go to completion. But wait a minute. In the problem we have already 3.0 mole of hydrochloric acid provided, and we require 0.50 mole, which means hydrochloric acid is present in excess 3.0 mole of hydrochloric acid, and we require just 0.5 mole, which means hydrochloric acid is the excess reactant. It is present in excess. We require 0.5 mole of hydrochloric acid, but we have available 3.0 mole. So excess HCl available. And this means the limiting reactant is magnesium. We're therefore going to base the reaction on magnesium. So the question now is direct. The question is, what mass of hydrogen gas will be liberated when 6 grams of magnesium reborn reacts with hydrochloric acid, excess hydrochloric acid? And now let us use the method of dimensional analysis. Let's start with the given mass of magnesium reborn, which is, let us start with the given mass of magnesium. So we have 6 grams magnesium. And dimensional analysis requires us to cancel this unit, gram of magnesium. So the target is the denominator. And what relationship can we draw? 1 mole of magnesium has a mass equal to the molar mass. So we have 24 grams of magnesium present in 1 mole of magnesium. 1 mole of magnesium has a mass of 24 grams. This sets up a new unit, mole of magnesium, which we can cancel out right away. So the target is once again the denominator. 1 mole of magnesium produces 1 mole of hydrogen gas, as we have seen. So we go straight, 1 mole of magnesium reacts with 1 mole of hydrogen gas. 1 mole of hydrogen gas. And the final relationship, we multiply again. We have set up another unit, 1 mole of hydrogen gas, and we have to strike that out. 1 mole of hydrogen gas. 1 mole of hydrogen gas has a mass equal to the molar mass of hydrogen. Molar mass of hydrogen, we have 2 atoms of hydrogen in 1 molecule. So right here we have hydrogen is 1, and then there are 2 atoms of hydrogen. 1 multiplied by 2, that's 2.0 grams of hydrogen in 1 mole. So we have it 2 grams of hydrogen. Beautiful. As you can see, the units cancel out already. So we have gram of magnesium, knocking out gram of magnesium, mole of magnesium cancelling mole of magnesium, and of course, mole of hydrogen cancelling mole of hydrogen. So the surviving unit here is gram of hydrogen, which is what is required. By using our electronic calculator, we come up with the final answer to this calculation, which is 0.50 gram of hydrogen. Very simple. These values can easily be managed. Of course, 6 divides into 24 4 times. Beautiful. And of course, we have this numerator here, 2 divides into this denominator 4 gives us 2. So 1 over 2, ultimately 0.50 grams, our final answer. Very simple. And that is actually the option A. Very simple and beautiful. All right. Attached to this video are quizzes that you can attempt to test your understanding of this video. In addition to this, the link in the bio and of course a link in the pinned comment takes you to a quick test to check your understanding or mastery of the topic chemical reaction stoichiometry. I encourage you to take the test. There are 20 questions to be taken in 30 minutes. And if you have a score of 80%, it shows that your understanding of chemical reaction stoichiometry is adequate. Thank you for being part of the session. And of course, I look forward to seeing you in my next video.